So I hope my screen is visible to everyone. Great. Uh, this is the program that was discussed in the last session. Yeah, this was about assignment number 2 of inheritance. We are going to discuss this also. Okay, I have received few questions on assignment 2 also. So I'm going to upload a detailed document of or test cases rather. What will be the input and what will be the expected output? Those test cases, one or two test cases, I'll be uploading for assignment number 2 today itself on the Moodle. So don't worry about it. Let me quickly delete everything and start from scratch how to perform optimized cloning. Let's say I have a class A and it have two variable. Let's say one is integer. Let's call it as ID, and then there is a second thing is in a integer array. Let's call it as ARR and not initialize. Fine. So this becomes my class whose object I want to clone. Now what we can do is we can provide a constructor in which we will at least allocate a memory to the array variable. See, the array is declared but not defined. So we'll define the array and I'll make it of size 1. So the class is ready. And now when we want to clone, we have to add a cloning mechanism to this class, right? We have discussed this many times now. Since last 2-3 lectures, we have discussed this. So I will call this method as clone. Now this is completely independent method defined by us and it has no relation with the base class method. To have that relation, we are going to make sure that our class E is implements clonable, which is an interface. And this interface is going to link our clone method with the clone method of the base class, which is the object in case of Java. Then let's what we'll do is we'll create a class for writing a main method. Let's call this class as first, right? And let's immediately write the main method inside this. Now let's create an object is equal to new a, and we will initialize id to 1 and object dot arr of 0. Let's initialize this value to something. Let's initialize it to 1. And then on the very next line, we will clone object into object 2. So we will call object dot clone. Now the cloning mechanism is coming in picture. The simplest way to create a clone is we all know that we have to write return super dot clone, and the Java's default cloning mechanism will come in picture and it will do the job. Now it works fine. This code works fine till the time you do not have any kind of reference memory types or reference members in the class. As soon as we start having reference types in the class, it starts creating problem with execution. Rather than calling it as a problem, it creates a clone, which is a shallow copy and not a deep copy one. And we always want a clone, which is a deep copy one. So how you can handle this mechanism? We have discussed a very different style in the video, which is available on Moodle. Now, let's see what we can do. And I was stressing on one point continuously since last 2-3 lectures, like everything in the Java is belonging to the base class, which is inheriting from the base class of Java, which is object. So I've stressed on that point many times, like whatever we do in Java is somehow getting linked to the base class of Java, which is a capital O object, right? So this is the base class of Java, and somehow everything what we do is inheriting linked to this base class. And this cloning mechanism belongs to the base class of Java, base classes of Java. So what we can do is, uh, so the clue given by me in the last session was like, I'll create a temporary object, a temp, and I'll store this super.clone. And now if I return this, return temp, right? Let's take care of typecasting. As the super.clone will return an object of base class type, which is a object, capital O object. We will take care of this. The same typecasting has to be taken care at this place. Like the clone mechanism is returning the type of object of base class of Java, and we are expecting a type of A class on the left hand side. So we are taking the care of typecasting very early. Second, I should handle the exception mechanism. As we have yet to discuss exception, what I'll do is I'll just say throws clone not supported exception rather than handling try and catch. So this is my code for clone not supported exception. Right. Let's try to compile this. CLS Java C first dot Java. Hopefully this will compile. Okay, unreported exception clone not supported. Let me handle this same exception here also. Throws clone not exception. And now let's try to compile. Yeah, it compiles. Now we haven't printed any value for object 2. So what we will do is we will say object 2 dot id is equal to 2. Object 2 dot arr of 0 is equal to 2. And then we are going to print the original object value, which is simple obj. We have modified object 2, which was clone of object 1. And now we will print id variable and array variable of original object to verify the values of this object are not modifying. Println object dot arr of 0. And we have seen this execution in the last sessions also, like it is not serving the purpose in the case of arr array. So you can see that the first value is intact, which is id, but the second value, which is of array, has been modified by object 2. So what is the meaning of this? This arr of object 2 and the arr of array of object are the same memory locations, and that is not expected in the deep copy. And this is not serving the purpose. So what we can do is we can simply write here temp dot arr is equal to, we can refer the current object by calling this keyword, as there is right now no what we can say a current object or something. What I can do is I can simply call arr dot clone, and now the same code will compile, which compiles and say Java C first. And now you can see the output. The original object array variable is not modifying. So this was a hint that I was stressing since last many lectures. Like everything in Java belongs to the base class of Java, which is object. And if you are somehow have a relation with the base class of Java, which is object, then you can call this cloning mechanism against your class. So if this array is somehow have a relation with the object class, then this array class can also call this cloning mechanism. And now by simply performing this cloning mechanism separate for this reference type, we have solved the issue of shallow copy. And now again, our object has become deep copy. So this was I was expecting from you people, but as I received many queries like how to do it, I'm giving the code to you. Now this is what was expected from the cloning assignment. This kind of a code I was expecting from the cloning assignment. Now what we will do is, see, this is there is even a further possibility of optimizing this code, right? So I will keep this question open. Now if anyone submits this kind of code, I will not accept it as a genuine submission, or I will not accept this code as a valid submission, because I have leaked the code which earlier I have expected from you people. Now I again stress on one point, like everything in Java belongs to the base class of object. Again, I'll stress on this point, and I expect even optimized solution for this cloning problem. So now again, I'll give a suggestion that there is a still scope to optimize this. There is a still scope to optimize this. Try to get that. Try to get that. Fine. So if any queries, quickly answer it in chat window. Sorry, ask me in chat window. I guess there are some questions already. I've just opened it. What is a return type of clone? Return type of clone is what we can define. Here we are defining it as an object. Why I defined it as an object? The answer is very clear. This is what we are doing in the person and student and teacher assignment. Like if you want to keep the teacher and student objects into a single array, then they must share something common, and that common part in our case is a person class. So in the same way, everything in Java somehow is possible to convert it to the base class, which who is the base class of Java? The capital O object keyword defines the base class of Java. So if everything in Java belongs to the base class, then somehow you can convert this object into the base class. So that's why the return type of the basic cloning mechanism will be object. So this was a question from Aditya. Aditya, have I answered your question? For at least the return type of clone method. Yes, okay, fine. So the next question was from Harshad. The question is, sir, I have already, okay, fine. Harshad, if the code is submitted before the date of this lecture, which is 27th August, if you already submitted the code before 27th of August, and I'll get the log if you modify it, don't modify the code now. If you have submitted the genuine code before 27th of August, then I'll accept the submission. If you are submitting it after the today or after today, then it will not be accepted as a genuine solution if this code I see, right? If you modify the code, then I'll get a modified date. In that case also, I will not accept the solution if I see this code, right? So I guess I've solved Harshit's problem. Harshit, is it okay? Okay, fine. The next question is uh, from Aditya itself. I have uploaded this code earlier. Okay, fine. So the same thing. Okay. So anyone have any doubt on this, or you got this concept? If anyone have any doubt, please post your questions in the chat window immediately. Otherwise, we will proceed with the interfaces. Okay, yes. I guess there is no question. There is a poll for everyone available. So I want you people to submit the poll immediately. Meantime, I'll take the questions in the chat box. Array type array ahe na. Okay. mg clone return object karat ahe. How? So we'll close the poll. And you will have results with you. So you can see that most of the people have got the correct answer. Some of the answers are a bit like, so here 8 people have been misleaded. Like, see, the everything in Java which is class must start with the capital letter O, right? So this object and this object is a different in case of Java. And the correct valid answer in this case is this B, which is a capital object. Here, clone, which I have stated as in a class, is not a class. It's a method. Cloning mechanism is a method. So 8%, 7 people have submitted the answer as clone, which is wrong. Super keyword calls the immediate base class. So this is the keyword which will help us to call the members of the immediate base class. So it is also a wrong answer, right? So correct answer, what is the base class of Java is object, right? Keep that in mind. Let's proceed. There's one question in the chat box by Aditya. The question is how this array, this mechanism is returning the object of type ARR and we are not handling it. So what I'll do is here I'll say A. And now my code also do not need to perform a typecast here. So I will not add a typecast. This code is fine because the return type is now changed to my class. And we have done it in the video, right? We have done the same thing in the video. Instead of using the base class, the A class, which is my own class, I used object. And now that's why I need the cloning mechanism, right? Or that type conversion mechanism. That's why I needed the type conversion mechanism. Whereas in the case of ARR, the returning object is of type reference. It's a memory type. And my left hand side is also a memory type. So when you are copying from memory type to memory type, I really do not need a type conversion because the return value is of type array. And my right side and the left side both are arrays. So I really do not need a conversion mechanism here. So what I'll write on this side, what do you expect me to write on this side? This, that to tell that the left hand side is of type array, or I should write this temp.arr, which is not exactly a type, So that's why I really do not need any type conversion in this statement, right? Because It is a memory type. Whereas in the case of array, you are returning a memory. The memory type, in the case of inheritance of our student and person and a teacher also, we have this dilemma. Like while converting from student to person, you can convert directly. But while converting from person to student, you have to perform a typecast, because person do not have an idea about what are the extra features which are available in a student class. We have discussed this, right? So, okay, there is an answer, reply from Aditya, like I got it. Great, fine. So I hope this is okay that we can proceed with interfaces task. And the question now for the other participants who haven't yet submitted the assignment is, you have to find even optimized way for completing this task. So there is still a more optimized way to perform this. This code would have been accepted as a valid submission earlier. Now it won't be accepted as a valid submission. You have to perform even better optimized code, which is possible. So let me create a new file, notepad file, and let's start with the discussion of interfaces, right? So let me open up notepad. Let me call it as a second.java, a new file, and I'll use a interface A. Now earlier we have used a keyword continuously, a class keyword, and now I'll say class B implements A. And we have discussed this in the last session that implements means you are responsible for providing definition of the contents which are included in the interface, and a class extends a class, right? Class extends a class and class implements the interface. So this session, we are going to strictly talk about interfaces and its feature. And in the next session, we will talk about the differences that we'll find between the class and interface. So this entire session will talk about, we will talk about interfaces now. Whatever the time remaining is with us, we will talk about only interfaces. Okay, fine. So what we will do is we will add another class. Let's call it as second, in which I'll write my main method. And now let me create an object of this. B's object is equal to new B. Now there is nothing in the class B or there is nothing in the interface A. So let's start exploring capabilities of interface. So I'll add a method called as data. Now this is an abstract method or a pure virtual method, right? Whose definition is not available. Now if I try to compile this program, Java C second.java, then we will get an error. The error message is B is not abstract and does not override abstract method data in A. So there are two solutions to solve this error or to remove this error. The first solution is add a method definition. I will add a public keyword because everything that we define inside the interface is by default public. So you are not supposed to write a public keyword in the interface. By default, whatever we write inside the interface, we have a public access modifier. So it is assumed or it is by default available, like interface A have a one method which is abstract method which is void data, and if somebody asks you what is an access modifier or a specifier for this method void data, then the answer is public, because by default everything in interface, whatever we declare inside interface, have a public access modifier. Now we will provide a method definition. I'll add some simple statement inside this println, and let me say this is default method of A implemented by B. So this statement is suggesting us that void data is a method of A and it is implemented by B. That's why we say that class B implements A. So we are providing implementation of the things which are declared inside interface. That's why this inheritance is called as implementation inheritance. Now let me try to compile this. So program is compiled. Now if we try to execute it, second, the program will execute. There will be no output because I haven't called the method. Let's call the method. object dot data, and now we will get the output. And Java first. Okay, I have executed first. Sorry, so I have to execute Java second. So this is the default method of A implemented by B. So this is what we have written. Now focus, listen carefully. Java interfaces do not support method definition. This statement was true till JDK 1.8 or JDK 8, simply say. In JDK 8, one modification has been introduced. JDK 8, why JDK 8 defined this modification or allowed this modification is the competing languages like C Sharp and other platforms started supporting method definitions inside interfaces. And Java has to adopt the change, which is getting percolated in the industry. And it also has to come up with a mechanism using which the programmers will be allowed to write definition inside the interface. Now, how the Java has done this? So let me write a method called as display and its definition system.out.println. Let's call inside this as this is this method. Now till 1.7, this is a horrible error. Like interfaces are not supposed to have any method definition, right? So if I compile even this, let me say Java C second, this is error. It says that disk interface abstract method cannot have a body. Like, so display method is abstract method and it is not expected to have a body. And the solution is suggested that B is not abstract and does not override a disk method. Okay, fine. So first of all, disk is not an abstract method. So and A is an interface. So we are not supposed to write a method definition. So this is the error what we are getting. And this same message you will see up to 1.7. Since 1.8, Java has done one modification, and that modification is you are allowed to use this keyword default. As soon as you add this default keyword, and if you recompile the program, second.java, the program will compile, right? And to be on important note, if I say object.dis, and if we compile and execute this, compiled, and if we execute this, the disk method will be called. You can see that this is a disk method. The call is getting executed. So this default methods are allowed inside a definition of interface. And this will work only from JDK 1.8 onward compiler. If somebody have an older compiler, then this feature is not available. Another important change is made by JDK. So we are discussing these changes as per the interfaces are concerned, right? So that's why this lecture remaining part is dedicated only to interfaces. The very important change which is available since 1.8 is, let me go like this. So interfaces are allowed to have variables also. I will let me write integer key, or integer, let's say integer, what should I call it? Fine, integer ID, which should not be changed. And let me call this as 1. So ID is a variable inside interface, and let's focus on only variable. And what I request you is assume these methods are not there. I'm not removing them; they are there, but assume these methods are not there right now, right? So forget about these calls. And what we will do is we will put a system.out.println call in the main method and object.id. So id variable is of interface, right? B is saying I am implementing A. So all the members of A are available in B now. And you are trying to access the ID variable with the object of B, right? Let's see whether it is accessible or not. Java C, the file name is second.java, and now to execute second. have I saved? Okay, there is a star mark. I haven't saved notepad file, so this was a mistake. Let me save this. Let me recompile and let me execute. So you can see that this ID value of the ID variable is available. Let's do one more thing. Object.id is equal to 2. Now we are trying to modify the value of ID variable. We are trying to modify the value of the ID variable. Let me compile. Now it says that cannot assign a value to a final variable. Here we have to stress on the word which is called as final. Cannot assign a value to final variable called as ID. So what do you mean by final? This is the constant variable from C++. So it means that the variable which is declared as final, we cannot change the value of it. So another very important take a point here is whatever members we declare inside an interface, are by default final, by default constants. You cannot modify the value of these members. Let's experiment with this one. Now what is this? You are declaring a variable, but you are not initializing this, right? And now let's try to compile Java C second.java. And it says that expected assignment. So the Java forces you to initialize the members which are declared inside interface, right? And this rule is from C++, like constant members must be initialized when they are declared. So instead of using a const keyword, Java is using a keyword which is called as final, right? Let me come to this conclusion by again showing you the error, Java second.java. And here the Java says that cannot assign a value to final member. So this final variable means constant variable. So Java has replaced the const keyword with the final keyword in case of its programming style. So we cannot modify the value of a final variable. And what do you mean by final variable? The variable is constant. Fine. Second, let me come inside this. Final integer k is equal to 22. It is absolutely fine to have a final variable in the main method or anywhere in the program. Now this is very fine program. It will even execute. And sorry, Java second I should write, and it should execute. Even you are able to print this value of final variable. Why we are making this distinction? We'll see immediately. Print variable, and I'll display the value of k. Let me recompile. Java C second.java. Clear the screen. And we can see the value 22 on the screen, right? So final means something which cannot be changed, a constant. Now let's come to the class. So what we will do is in the class B, rather than making it complicated, I will use another class. Let me call this class as class C. Fine. And here I'll make a variable final integer ID is equal to 1. And we know that this variable is a constant variable now because it is declared as final and you cannot change the value of it. So let me delete the rest of the part from my executing program. Let me keep only class C. And now let's create two objects of class C. C object is equal to new C. This is the first object, and we'll be able to print the value of the final variable C.id, right? And let's compile Java C second dot Java, and sorry, C.id cannot find symbol. Sorry. So the biggest mistake, I should use here object, not class name. Java second, and now we should get id as 1. Fine. And there is another variable which is called as static end k. Let's initialize this k to 1, and this both things are possible. Java C second dot Java and Java second. So it works fine. So there is a difference in static and final. Static means all the objects are going to share the same memory, whereas the final means it is common, or it is value cannot be changed. Value cannot be changed. So if I create another object, C object2 is equal to new C. Now we have two objects, and if I print the value of this object2.id, still I'm going to get the same value because the value of the final variable cannot be changed, right? On the other hand, if I print the value of k variable, still I'll get the same value because static variables are common among all the objects, right? Final, we cannot change, so its value will be same for all objects and you cannot modify it. Static, the same memory is shared by all the objects, right? The same memory is shared by all the objects. So again, the value is going to come as same. But one small modification, object.k is equal to 22. This thing will allow, it is allowed. You can modify the value of k because k is not final, k is only static. But if you modify the value of one object, that value will be reflected into all the objects, right? So this is the setup. Let's try to compile javac second.java compiles, and let's try to print everything on the screen. Here you can see that this 1 is the output of this first two println lines, and that's why the output is 1 and 1. The second 1 is the value of this k variable, and output of this two println lines. After that, we have modified the k variable only for the object, right? And we are then printing object as well as object2. As this k is a static variable, means its memory is getting shared among all the objects. That's why when you modify object.k, it is updated. But as the same memory is getting referred between object and object2, object2.k is also modified to 22. So this is somebody has unmuted. Anyone have a question? I'll open the chat box. Okay, fine. There is one question from Aditya in chat box. If we declare variable inside default method in interface, then is that a final or not? Okay, you can try that. You can try that. Fine. So instead of deviating, let me come back to this particular very important point. Final int id, static int k are two variables. Final is a variable which cannot be changed, and it is common among all objects, but the memory is going to be different. Memory is going to be different because final and static is a different story. Final means you cannot modify the value, but each object is going to have its own copy of final variable. In the case of static, you can modify the value of the variable, but all the objects are going to share the same memory. So that is the difference between final and static. And to be on the third side, okay, this change is again available since JDK 1.8. Before that, the story was like this: final static integer j is equal to 2. Now, what is the meaning of this code? This code means the value of j cannot be modified, as well as the static means the j is available to all the objects. That means the same memory is getting utilized by all the objects, plus you cannot modify this. So this was the valid statement. This is the valid statement in all the JDKs. Up to 1.7, this is the valid statement, and this was not the valid statement till JDK, what we can say, JDK 8, integer, let's say j2 is equal to 23. Now, this was not the valid statement. Now this is also a valid statement. What JDK 1.8 onwards standard says is, if you have two access modifiers, if you are using two keywords from Java in any order, like final static or static final, it is not going to change the meaning of the definition of that member. So final static or static final will create the same definition of variable G. What does this mean? This means that the variable's memory is common among all the objects, as well as you cannot modify the value. And what is the meaning of the second statement? The same meaning. Like it's a common variable and you cannot change the value of the variable. So the both lines do the same job. And if you compile this, as I have a JDK version above 1.8, this is going to compile and work fine. If anyone have a JDK version 1.8 below, then this is going to create a trouble on the second line. This is not a valid line in below JDK 1.8. The above line is the valid line, final static. So JDK 1.8 says that if you are having multiple keywords from Java coming on the same line, or access modifiers or variable type define keywords are coming on the same line, then the meaning is not going to change. So final static or static final means the same thing. Like the memory is common as well as you cannot modify the value. So there is a quick question coming in the chat box. You will have only 2 minutes to answer that. The question is coming just now. Sorry. So you quickly, the poll is open. Quickly give the answers. You have only 2 minutes. So the results are ready. And So you can see this is the result which is available, and so 40 people have like chosen the wrong answer. We cannot change the static variable. That is wrong, false. So 40 people have selected the wrong answer, and we were discussing the only thing which was interface have a static member, final members that cannot be modified, and static means you can modify, right? So 40 people have got the wrong answer. So we have to work on this. So I'll quickly repeat this. So this poll has given me insight that something is wrong. This is not the correct answer that you people are giving. Let me save it in my documents. Fine. So let's close this. See guys, what we are doing. This, let me cut this. So this k is a static variable, right? And the moment I go, you see, have seen this that we modified the value of k, and it was possible that you can modify the value of a static variable, right? So we cannot modify the value of a static variable was a wrong statement, false statement. So we are able to modify the value of a static variable, and that is what we have seen in the program, right? So wake up here, like we can modify the value of a static member. We cannot modify the value of a constant member. And how to create a constant member in Java? Create the variable using final keyword. So remember, you can modify the value of a static variable as many times as you want. So after this also, what we can do is, after this also, you can Control C and let me just update the value to 25. So earlier it was 22, now it is going to be 25. We can compile this and let's say Java second. And you can see that the value of both the variables have been updated 25. So what do you mean by static? Static means common memory among all objects. Common memory among all objects. And you can modify the memory. But as the memory is common among all objects, if you modify the variable using one object, it will be reflected into all the objects. So here, let's do what we can do is, while modifying the second time, I'll use object number 2. I will use object number 2 and let's recompile. And you can see that even if I'm modifying using object 2, the value of object 1 is also modified. Here, you can see that the object 1 is modified. So all the objects are sharing common memory because the variable is marked as static. As soon as you are using a common memory, if any of the object modifies, you will get the result into all the objects. But static variable can be modified. On the other hand, if you mark the variable as final, that means it's a constant variable. And constant variable value cannot be changed. So you cannot change the value of id variable anywhere in this program. If you try to modify this id variable, then that's a compilation error itself. If I try to compile now, let me try Java C first. Sorry, the program name is second.java. It says that you cannot assign value to a final variable because final means constant. So that's the major difference in a final and a static. And the next line says that you can create a variable which is final static integer, let's say j. What is the meaning of this? The variable is having a common memory because it is declared as static. So all the objects are going to share the same memory, as well as it is marked as final, means nobody can modify. And the same effect can be achieved by saying static final integer j is equal to 22. So these both statements are very equivalent. This is a valid statement since the inception of Java. This is valid statement since JDK 1.8. So after 1.8, Java says that doesn't matter how you use multiple keywords on a single line, the common meaning will be retrieved. So final static integer j 22, static final integer j 22 remains the same thing. That what it means, the variable is having common memory as well as the variable is declared as final, so you cannot modify it. So again, a quick poll. a new question is going to come. So you have only 1 minute to answer this. The poll is open now. You have only 1 minute to answer this. Quick answers. So here only 9 people got the wrong answer. Most of the people have got it correct. So this is a session time up also. Now I know exact point where I have to start in the next session. So in the next session, we'll start with the static and final, and again classes and interfaces. So remember, the original discussion point is an interface because it have only final members, and we cannot modify the value of final members. But the question here was static variable shares the common memory among all objects. So that is true. Only 9 people have got the wrong answer and 11 people haven't submitted the answer. So we will stress on the same point in the next session. You can quit this meeting and join the next lecture. No problem. So I'll post the next meeting. We are going to have it on the Friday. So we will wait that time. Thank you. You can quit the meeting now. No problem.
You know, man.